Hey guys, today we're going to be looking at dilations on shapes using the coordinate plane. So the first thing we want to look at is what a dilation even is. And a dilation is a transformation, which means it changes a figure. And this is when a figure is enlarged, meaning it gets bigger, or reduced, meaning it gets smaller, using a scale factor. And now this scale factor is how much it's enlarged or how much it's reduced. To dilate our figure on the coordinate plane, we multiply the coordinates of each vertex or each point by the scale factor k. So our algebraic rule, which is what a lot of you guys will see, goes from the original point, so this x and y refers to the point that is on the pre-image, and then you multiply the x-coordinate by the scale factor and the y-coordinate by the scale factor to get the point for the image. So let's say we have point A, which is at 2, 4, and our scale factor is 2. Then to get A prime, I would take x, which is 2, multiply it by the scale factor, which is 2, and get 4. And then to find the new y-coordinate, I would take the original y, which is 4, multiply it by the scale factor of 2 to get 8. So we have our pre-image point and then our image point. When k is greater than 1, so when our scale factor is greater than 1, the dilation is an enlargement, meaning it gets bigger. But when k is between 0 and 1, meaning it's greater than 0 and it's less than 1, the dilation is a reduction. So some examples of a scale factor greater than 1, that could be anything like k is equal to 2 or k is equal to 5/3. Notice that just because it's a fraction, you have to look and realize it's an improper fraction and it's really equivalent to 1 2/3, so that is greater than 1. The same when we want to find something between 0 and 1. K could equal 1/2. K could equal 0.5. So those are the same scale factor. One is just expressed as a fraction. One is expressed as a decimal. Or even 2/3. So again, it's still less than 1. So it would be reducing the pre-image or the original figure. So triangle ABC is dilated, so we're looking at an example on a coordinate plane, with respect to the origin by a scale factor blank, so we don't know the scale factor right now, to create the image of triangle A prime, B prime, C prime. So I see, I'm going to highlight it, that my original triangle is right here, and I know that because it does not have the prime notation symbols on it. And so we're going from yellow to the outer blue, which means that my triangle enlarged, so my scale factor has to be greater than 1. And I can find my scale factor, which is k, so k is equal to scale factor. I can always find it by comparing the ratio of the new, so whether that's the new side, the new coordinate, or the new perimeter, to the old. So I'm going to take a look at point C and point C prime. So I see that point C has a y value of 2, and point C prime has a y value of 4. So my new y value there is that positive 4. My old y value was 2, and I know 4 over 2 simplifies to a positive 2. So my scale factor is a positive 2. And let's see if that works for our coordinates. So we have A at 3, 1. And to find A prime, we're going to take 2 and multiply it by the x-coordinate, and take 2 and multiply it by the y-coordinate. So I get 6, 2, which matches my new shape, so that one works. Negative 1 times 2 is just negative 2, and negative 1 times 2 is negative 2. And again, that is where B prime is on my image shape. 2 times 0 is just 0, and 2 times 2 is 4. And lastly, that is the third and final point. So we know our scale factor was 2. So to create an algebraic rule describing the dilation, which we've kind of already done, we're going to say that our pre-image, which is xy, so our starting point, then became 2 times whatever x was and 2 times whatever y was, because 2 is our scale factor. And we're going to look at one more. We're going to draw the rectangle WXYZ and its image after a dilation with a scale factor of 1/2. Well, 1/2 is between 0 and 1, so I automatically know this is a reduction. And I'm going to plot the points. So -2, -2, and that is W prime. X prime at, or excuse me, not W prime, just W. X is at -2, 3. Y would be at 5, 3. And Z would be at 5, -2. So here is our rectangle. Now to find W prime, X prime, Y prime, and Z prime, I'm just going to take all of these original points, and using the scale factor, I'm going to take half of the x and then half of the y value. So half of W, -2, that's a -1. So my new point is at -1, -1. X prime, so half of -2 is still -1, and half of 3 is 1.5. So -1 and 1.5. Half of 5 is 2.5 to find y prime's x coordinate. And then half of 3 is 1.5. So y prime will go at 2.5 and then 1.5. And then z prime will be at 2.5 and -1. So here we have our new image, which is our new rectangle. But we want to write an algebraic rule. So again, our pre-image, which is xy, to find our new image, we took the x coordinate and we took half of it. And we took the y coordinate and we took half of it, because 1/2 was our scale factor. And we can see on our graph that this was a reduction. All right, thank you.